So I've recorded the class. So last class we were doing determinant, and the last question that was done was question number 14. Now we move on with question number 15. Okay, everyone, question number 15. Okay, Reva also has joined. Elisiba, okay, Manila. So look at the board, everyone. So this is questions on determinant. As I've already told you, the 20 formulas which I had given you on determinant, on matrices. You see that all the properties that we are using out here, or out here, are given in those formulas itself. Is that clear? So I'll be explaining it to you also. For instance, in this particular question that we are going to next, we have uh, we have used three properties. Okay, so question number 15, everyone. Question number 15 says, if A is a non-singular matrix, so you need to understand the meaning of a non-singular. What is the meaning of a non-singular matrix? That means a matrix whose determinant is not equal to 0. So if a matrix, the determinant is not equal to 0, then we can say that A inverse exists. This is just for you to understand. So A inverse exists. Okay, so what is given is A is a non-singular matrix of order 3. So the value of n is 3. That means it's a 3 cross 3 matrix, 3 rows and 3 column, such that A square equal to 3A, A square equal to 3A, then the value of determinant A equal to question mark. Then the value of determinant A equal to question mark. Okay, let's see whether you'll be able to solve this question or not. See, these questions which we are doing, the previous 14 and the remaining questions, all are probable and very important questions. So see, since I need to find the determinant, since this is given, so I'm gonna apply determinant on both sides. So determinant of A square equal to determinant of 3 into A. Yes or no? Next, A square, A is a matrix, so it can be written as A into A is equal to determinant 3 into A. After this, I can use two properties of determinant. Property number 1 says determinant of AB will be written as determinant A into determinant of B. So determinant of A into A can be written as determinant of A into determinant of A. I have used this property in the previous question. And the second property, a very important property, which says determinant of a scalar and a matrix. Because 3 is a scalar, determinant of a scalar and a matrix is the scalar comes out k to the power n into the determinant A. So 3 is a scalar, so 3 comes out and the order is 3. So 3 to the power 3 into determinant A. And since determinant of A is not equal to 0, I can cancel determinant A and determinant A. So the value of determinant A equal to 3 3s are 9, 9 3s are 27. So question number 15. Question number 15, the correct answer is 27. Question number 15, the correct answer is 27. Those who joined late, let me explain one more time. They have said that A is a non-singular matrix. Non-singular matrix means the determinant of A is not equal to 0. That means A inverse exists. Next, the order of the matrix is given to be 3 and it is given A square equal to 3. I have to find the determinant A. So see how I did it. I apply determinant on both sides. So if you want, you can take a screenshot of this, or I'll be sending you the notes of this just after I complete this. Okay, so I think that will be better because the questions will be written. So question number 15 is done. So tomorrow, please everyone, I'll be starting a new topic, relation. Please don't forget to attend that class. So relation function and inverse will fetch you 20 marks. So these chapters we have already done before, so it'll be just a revision for you. So now we move on to question number 16. Question number 16. Okay, so it's given f of x. F of x is determinant x minus 4, 5, 1, 1 minus 2, and 2x1. I have to find f dash 5. So options are given. 4 options are given. F dash 5. I have to find f dash 5. Okay. So everyone, how do we do this again? Now fx is given. What is fx? Fx is a determinant. So fx is a determinant. So I can expand this determinant very easily. You know how to expand a determinant. A determinant can be expanded through any row or any column, isn't it? So let me expand the determinant to the first row. Why? Because the sign convention is easy. Plus, minus, and plus. So what are the cofactors of x? Cover the row and column. 1 minus 2x and 1. So how do you multiply diagonal elements? 1 into 1 is 1 minus x into 2 is 2x minus 2x. So minus into minus becomes plus 2x. Minus in the middle, it is minus 4. So minus into minus is plus 4. What are the factors of 4? Cover the row and column. So 1 into 1 is 1. Minus in the middle, 2 into minus 2 is minus 2. Minus into minus becomes plus 4. Plus 5. What are the factors of 5? Cover the row and column. 1 into x is x minus 2 ones are 2. So what do you get? So what do you get? Open the bracket. X into 1 is x plus 2x into x will give you 2x square. 4 plus 1 is 5. 5 fours is 20 plus 5x minus 5 twos are 10. So what do you get? You get 2x square plus 5x plus x will give you 6x plus 20 minus 10 is 10. So this is the value of fx. But I have to find f dash 5. And you know dash means you are differentiating the function. So differentiating with respect to x, you get f dash x equal to 2 comes in front. So 2 twos are 4x plus derivative of 6x is 6 and derivative of 10 is 0. So what is f dash 5 everyone? F dash 5 is 4 into 5 plus 6. 5 fours are 20 plus 6 is, so 26 is the correct answer. So this one was question number 16. This one was question number 16. Okay, now question number 17. I love this. Question number 16. So this one was question number 16. Now we move on to question number 17. Okay, question number 17. Question number 17, a very important question. We have done these type of questions. So since it's important, so I'm doing it again and again. So this is question A, capital A is 2 minus 2 0 0 0 minus 2 0 and 0 0 minus 2. I have to find the determinant of the adjoint A. So, if you don't know the technique, what are you going to do is simple knowledge based. How are you going to do? You have to find the determinant of an adjoint. You know how to find the determinant, but the problem is you don't know the adjoint, isn't it? So what you will try is you'll try to get the adjoint of this determinant, which is a long process. So obviously it'll take a lot of time, isn't it? So that is one way of doing it, but this can be done in a very easy way also. How? For that you need to know the properties of a determinant. You know, determinant of adjoint A is determinant of A to the power n. That means to find the determinant of adjoint A, you need not find out adjoint A. Finding the determinant A is more than enough. Is that clear? So, and I have to find the determinant of this, and the finding the determinant of this is so easy. Why? Because this is a special type of a matrix. What is this? It's a diagonal matrix. On top of that, it's a scalar matrix. So to find the determinant of a scalar matrix, you simply have to multiply the diagonal. So minus 2 into minus 2 into minus 2. 2 twos are 4, 4 twos are 8. So determinant A becomes minus 8. Therefore, what's going to be adjoint 8? Did you see it? Very important problem. So it is what? A determinant A to the power n minus 1. So determinant A is minus 8. N order 3 rows and 3 column. So 3 minus 1 is 2. So 8 8s are 64. So the adjoint of this particular determinant is 64. So this one was question number 17. So this one was question number 17, a very important question indeed. Okay, now question number 17 is also done. Okay, another important question, question number 18. Let me see how many of you will be able to solve this. Okay, if A is a square matrix of order 3, So whatever you know, you just write it down. So every time you might be wondering why they always talking about a square matrix, square matrix, square matrix? Because the only link between a matrix and a determinant is square. A determinant cannot be a rectangular matrix. That means a determinant cannot have number of row and number of column different. So the moment they say that A is a square matrix, it has to do something with a determinant. Is that clear? So the order of this matrix is given to be 3, and they have given that A into adjoint A into adjoint A equal to 10i. A into adjoint A equal to 10i. I have to find the determinant of adjoint A. I have to find the determinant of adjoint A. Another important question. For this also again, you need to know the property of adjoint, everyone. You need to know the property of adjoint. So I'll just write down the property. We know, see, what did I tell you? Finding the determinant of an adjoint, finding the determinant of an adjoint is very easy, because if you find out the determinant of the matrix, then the determinant of the adjoint can be found easily. So the first task is to find the determinant of the matrix. So we know that A into A inverse, the matrix into its inverse is identity, but the matrix into its adjoint, the matrix into its adjoint will give you determinant A into identity. Don't forget this very important concept, or rather very important property. A into adjoint will always give you determinant A into I. So A into adjoint A is already given, that is 10i equal to determinant A into I. So I and I gets cancelled, so the value of determinant A is 10. So since you got the value of determinant A, finding the determinant of adjoint A is a very easy task. So n minus 1, what is determinant A? It is 10 to the power n, is order is 3 minus 1. 3 minus 1 is 2, so 10 square is 100. So what is the determinant of the adjoint? It is 100. So this is question number 18 for you. This is question number 18 for you. Okay, next question, please. Okay, question number 20. Okay, question number 20. Question number 20 says if A equal to determinant A B C D, sorry, not determinant, matrix A B C D, and B equal to matrix 1 0 0 1, I have to find the adjoint of AB. I have to find the adjoint of AB. So how will you proceed, everyone? One way of doing it is you multiply A and B, whatever matrix you get, then find the adjoint of that. Okay, and that is one way, the normal way. So since we already know one property, let us use that, because property might be useful. So you know adjoint of AB, you know whenever there's a multiplication sign between a matrix, the order of the matrix changes. That means the position changes. So the adjoint is gonna go in front. So it's gonna be what? Adjoint of B into adjoint of A. This thing has happened many times. I'll just explain it to you. So AB inverse. Inverse of a matrix is gonna be B. In the inverse is gonna go inside, but it's gonna be B inverse plus A inverse. Similarly, AB transpose is gonna be what? B transpose, sorry, this I wrote not. B transpose into A transpose. The same concept has been applied out here. Now, can you tell me how do you find the adjoint of a 2 cross 2? How do you find the adjoint of a 2 cross 2? I taught this in the previous class also. So those who don't know, just see. To find the adjoint, you simply interchange the position of the first diagonal. That means this is the first diagonal. So when you interchange their positions, since the numbers are same, so it will be same only. Now you change the sign of the second diagonal. Second diagonal is 0 0, so it becomes minus 0 minus 0. But since 0 minus 0 does not exist, so it becomes 0 0. So adjoint B and B is same. Adjoint B into B is same. Okay. What about adjoint A? Adjoint A, the first diagonal we change at position now. A will become D and D will become A. Second diagonal, the sign is going to change. Positive B will become negative B and positive C will be negative C. So this is, those who don't know, this is how you find out the adjoint of a 2 cross 2. Now to multiply, I hope you have not forgotten how to multiply. The rule is row 1 column 1, row 1 column 1, row 1 column 2, row 2 column 1 and row 2 column 2. So please help me multiply this. Row 1 into column 1. First with first, second with second. 1 into D, D, 0 into minus C, 0. Next, row into column 2. 1 into minus B, 0 into A, 0. Next, row 2 into column 1. This is row 2 and this is column 1. 0 into D, 0. 1 into minus C, minus minus C, and finally row 2 into column 2, row 2 into column 2, 0 into minus B is 0, 1 into A is A. Is that clear? So what did you get this to be? This is nothing but, sorry, this is nothing but adjoint of A. So in the option, in the given option, in the given option, this is going to be adjoint A, because see, you could be clever enough and instead of doing this, you know this is an identity. Yes or no? So identity into any matrix will give you the matrix itself. So you did not have to multiply also. Is that clear? But the reason I did it is in future you might you might have to multiply a 2 cross 2 matrix. So it's better you understand. Is that clear? Identity into a matrix will be the matrix itself. Okay. So this is question number 20. This is question number 20. Okay, now let us do question number 21. Okay, everyone, question number 21 is if A is a square matrix, if A is a square matrix such that capital A minus 2i, capital A minus 2i into A plus I is equal to 0. A plus I equal to 0, I have to find A inverse. I have to find A inverse. Okay, in order to find A inverse, you already know the technique. What you need to do is you need to simplify this first. Open the bracket. What do you get? A into A. You can write A square or you can write A into A only, no problem. A into I, matrix A into I will give you A, because A into an identity, a matrix into its identity will be the matrix itself, minus 2I into A will again give you A, minus 2I into I will again give you I. 1 into 1 is 1. So what are you getting? A square plus A minus 2A will give you minus A minus 2I equal to 0. Now I have to find, everyone listen to me, I have to find A inverse. A quadratic equation is given. So you know how to find A inverse. What do you do is, every time you have to find an inverse, and when inverse is not given, you multiply both sides with A inverse. You could have taken this to the right and multiplied, or leave it out here and multiply. The choice is yours. So multiply each and every term. What do you get? A inverse into A square minus A inverse into A minus 2I into A inverse. As 0 is a null matrix. Null matrix into A inverse will give you null matrix. 0 into anything is 0. Next, A square can be written as A into A. Yes or no? Minus A inverse into A, you know it is identity, minus 2 A inverse into an identity is A inverse. Next, What is A inverse into A again? It is I. So I into A will give you A minus I minus 2A inverse equal to 0. So capital A minus I equal to negative goes that and becomes positive. So take 2 down. So A minus capital I divided by 2 equal to A inverse. So what is A inverse, everyone? Capital A minus I divided by 2. So out of the four option, the right option is capital A minus I divided by 2. This is the correct option. So this is question number 21. Everyone, okay. Uh, So once you are done, so one good thing for you all, once I complete this chapter, because I'm left with only relation function and inverse, that also won't take much time because I have done this. I think this will be, if I do this, this is going to be my fourth time doing relation and function. Okay, so once I complete that, the videos are already there. So once I complete that, then what I'm going to do is I'm going to do a lot of model test papers, solve model test papers. Okay, set 1, set 2, set 3, we are going to solve. So I want you all to start revising all the topics so that you will understand better. That means it'll be a revision for you all. Okay, if you don't revise, then again it'll be as if you are doing it for the first time. So now question number 22. This was an ISC question. If you get a difficult question, then we cannot ignore these type of questions also. 1 minus 4, 3 minus 2, capital X, and minus 16 minus 672. So the question is to find capital X. The question is to find capital X. The question is to find capital X. So how do you do it? So look at this. I'm just making this equation simple. Let me take this as A, so this becomes what? AX. And let me take this as B. So it becomes AX equal to B. So doesn't this look familiar to you? This is the basics of Martin's rule. Remember? So what's going to happen to this A? A goes down. So it becomes B by A. Since you cannot divide two matrices, what will you do? You are going to bring A up. So it becomes A inverse B. So to find capital X, the formula that I'm going to use is A inverse B. B we already know. The only thing I need to find is A inverse. So A inverse, you know the formula. What is A inverse? It is adjoint of A divided by determinant A. So let me first find the determinant A of A. This is A, isn't it? How do you find? 1 into minus 2 is minus 2. Minus in the middle, 4 3s are 12, minus 12. So this becomes plus 12. That is equal to 10. You got the determinant A. Now the adjoint A is nothing but 2 cross 2 matrix. So how do you find the adjoint of a 2 cross 2 matrix? You interchange the diagonal elements. So instead of 1, you write minus 2. And instead of minus 2, you write 1. And just change the sign of the second diagonal. So plus 4 will be, sorry, minus 4 will become plus 4. And plus 3 will become minus 3. So you got the adjoint also. Now capital X equal to A inverse is what? Adjoint by determinant. Determinant is in the denominator. So let me write down 1 by 10. The adjoint you got it to be how much? Minus 2, 4, minus 3, 1 into B. What is B? Minus 16, minus 6, 7 and 2. Now what you need to do is you simply have to multiply them, isn't it? And you know the rule. I've already taught this. Row 1 into column 1, row 2 into column 2. So see, minus 2 into minus 16 will give you 32. 32. 4 into 7, there's no sign, so means plus. 7 4 is 28. Minus 2 into minus 6 will give you 12. 4 into 2 is 8, no sign, so means plus. Move on to the next. Minus into minus is plus. 16 into 3 is 48. 48. 1 into 7 is 7. Okay. Minus 3 into minus 6 will give you 18. Plus 2 ones are 2. So you get 1 by 10. What about this? When you add this, you get how much? 60. When you add this, you get 20. When you add this, you get 55. And when you add this, you get 20. You can leave the answer till here, or if it does not match the option, then divide each and every term by 10. So on dividing each and every term by 10, you get 6, 2, 2. 55 divided by 10 is 11 by 5, 2 is 10, 11 by 2. So this will be one of the given options. This will be one of the given options. So I hope this explanation is okay. Now we move on to the next question. So question number 22 is done. Okay. Uh, this question number 23, everyone. Question number 23 says capital A is cos alpha. You got minus sine alpha 0, sine alpha, cos alpha. This is 0. So 0, 0, 1. So you have to find the inverse of the adjoint. So inverse of the adjoint. So everyone, whenever you see a 3 cross 3 matrix, 3 cross 3 matrix, and they are talking about finding the inverse, then obviously they mean you have to use the properties, not the long method. Is that clear? So just imagine A equal to this and you have to find a adjoint of A inverse. So what does that mean? First I have to find the adjoint of this, then again find the inverse of that adjoint. So it's gonna be a long process, isn't it? So obviously they don't want you to solve that method. They want to see whether you know the formulas that were taught or not. Okay, so this is A is known, and we can find out the determinant of this and adjoint. So we see that A is known, adjoint and determinant. So we know one formula: A into adjoint A into adjoint A is determinant A into I. I just use this formula. A into adjoint A is determinant A into I. So I need to find adjoint A to the power minus 1. That means I need to take this to the denominator. So how do I do that? A equal to determinant A into I. Determinant is a scalar quantity divided by adjoint A. Next, capital A equal to determinant A into I plus goes up and becomes what? Adjoint A to the power minus 1, isn't it? So capital A equal to determinant A into identity into any matrix, because see, adjoint A, inverse of an adjoint A is also a matrix. So a matrix into its identity will give you always adjoint A to the power minus 1. I need to find this, so determinant goes down. So A divided by determinant A is nothing but adjoint of A to the power minus 1. Adjoint of A to the power minus 1. So you can see clearly that you simply have to find the adjoint of, sorry, the determinant of this matrix. And don't think that Ambo finding determinant of a 3 cross 3 it's long. Look at the question properly. Look at the question properly. The hint lies in the question itself. The hint lies in the question itself. Look at row 3 and column 3. Look at row 3 and column 3. Row 3, two elements are 0, isn't it? So what do? We expand through row 3 and see what do you get. So everyone, look at the board. So determinant A expanding through row 3. I don't have to expand through this. I don't have to expand through this. I just have to expand through this. So row and column. So cos alpha into cos alpha will give us cos square alpha, minus in the middle, sine alpha into minus sine square alpha will give you minus sine square alpha. So that is plus, and this is 1. So determinant of A is 1. So from here you put the value. So the answer is just A. So out of the four options, the right option is adjoint a to the power minus 1 is nothing but a. Okay, now I just got one last question. So everyone just pay attention, please. Question number 24. Question number 24. A similar type of question had come in the specimen paper. You can just have a look, specimen paper, but this is a bit difficult one. The question that is given in the specimen paper is based on the same concept, but it's easy. So that I'm leaving it for you to do it. So the next question, everyone. Okay, question. Okay, yeah. Question number 24. The question is determinant log 512 to the base 3 log 3 to the base 4 log 8 to the base 3 and log 9 to the base 4. I have to find the value of this determinant. I have to find the value of this determinant. So the only property that you need to know to solve this is, everyone look at the board, log a to the base b, a to the base b can be written as log a divided by log b. And the second property, log a to the power x is the power comes in front. So you get x log a. So please keep in mind these properties, okay? So let us begin, everyone. So when you multiply these two, what do you get? When you expand the determinant, log 512 3 into log 9 to the base 4 minus in the middle log 8 to the base 3 into log 3 to the base 4. Okay, next, log a by b, you know what is it? It is log a divided by log b into log a divided by log b minus, do the same thing, log a divided by log b into log a divided by log b. Okay, now I need to cancel the log. So what I'm going to do is I'm going to convert everything into 2, 3 and 5 because these are prime numbers. What are these? Prime numbers. So I'll just skip a few steps. So look at the board, everyone. I'll just skip a few steps. So 512 is log 2 to the power 9. So what happens to the power? The power comes in front. So log 512 can be written as log 2 to the power 9. So 9 comes in front. So you get 9 log 2 divided by log 3 as it is because it's a prime number. 9 can be written as 3 square. So log 9 can be written as 2 log 3 because this is 3 square. So square comes in front. Log 4 is 2 square. So 2 comes in front. So 2 log 2 minus log 8 is 2 to the power 3. So you have 3 log 2 divided by log 3 into log 3 divided again 4, 2 square. So it's going to be 2 log 2. Now cancel, everyone. Cancel. What do you get? Log 2 and log 2 gets cancelled. Log 3 and log 3, 2 and 2 also gets cancelled. So you're just left with 9. Log 3 and log 3 gets cancelled. Log 2 and log 2 gets cancelled. So you're left with 3 by 2. What is the LCM? The LCM is 2. 9 2s are 18 minus 3 is 15 by 2 is the answer. So please go through this 15 by 2. So I have sent the solutions that was taught today in the group right now. You have, I think you have already got the solutions. I've already sent that. Okay, so I want just a minute, please. Okay, just go through this. Okay, the question that I was talking about that had come in the specimen paper, I'll just drop this piece. So the question that had come in the specimen paper, so similar to 24 was, I'll just write it down. So the question was, everyone, the question was, uh, everyone look at the board. Determinant 1 log b to the base a log a to the base b and 1, and four options were given. Four options were given. So this can be done easily. Okay, next question that was given in the specimen paper. Look at this. This is the value of the determinant. It is given as ABC X Y Z PQR. Then I have to find the value of this, everyone. KA, KB, KC, KX, KY. Such easy questions that were given in the specimen paper. KR. Okay, so how do you do this? It's a determinant. So look at the first row. What is common? K is common. Look at the second row. K is common. Third row, K is common. So what do you get? K cube. So if I take K out, what do you get? A, B, C, X, Y, Z, P, Q, R. So this is question number 7, and this is question number 12 of your specimen paper. So this can be written as K cube, and this is nothing but delta. So the right option is K cube delta. So you can take a screenshot of this. So we are going to do this much for today. So tomorrow I'm going to start off with relation. Is that clear? Good night, everyone.